Hello, welcome to this Houdini beginner tutorial series where we're going to be recreating this Sandmonster effect. This is an effect that I've used in many of my videos and have been highly requested to make a tutorial on. And if you want to see more tutorials of my future work, please make sure to like and subscribe. So let's just get into it. Alright, so to get started, you of course want to download Houdini, and you can do this from this website. And just make sure you get the one for your operating system. And speaking of operating systems, in this tutorial I'm going to be using Windows, so some of the hotkeys might be a little bit different for if you have a Mac. The main difference would probably be that when I say control, you're probably going to have to use command. But other than that, this tutorial should work for everyone. Cool, once you have it downloaded and open your software, we're going to first make sure we set the scene up correctly. And you do this by going into this file menu and then new project. And in here, it'll set up a project automatically for you with a bunch of folders for you to place in your caches and renders and all that. By default, it goes to this $home variable, which is a Windows variable where it'll store your files on your disk. And I'm fine with this one. You could place it somewhere else if you want, but I'm just going to keep the default. And then we can set the project name up here. I'm just going to call it tutorial Sandmonster. And I'm also gonna just Control-A, Control-C to copy it, because this will it won't save the file, it'll just create the folders. But if you hit Control-Shift-S, it'll take you to, let's see, here you can see all my projects. And if I sort by last modified, this first one will be the one we just created, the folder with all these folders inside. And I'm just gonna go ahead and paste the name of this folder so I can save it. And if you do Control-Open, you can see now we have saved a hip variable or a hip file inside of this folder where we're going to be working on our project. Alright, so to get started creating our effect, we're going to place down a grid, and you do this by going into this network right here, hitting tab, and then you can type whatever you want. And in here you can see you have access to a bunch of different nodes, but we're going to just place down a geometry node because we want to add some geometry into our scene. So just hit tab, search for geo, and put down a geometry node. And I'm just going to call this work area, as I'm just going to be doing all my work inside here. And once it's placed down, you just double click on it to go inside. And inside here, you can see if you press tab, you have access to a bunch of other nodes. And these are going to be, inside here, we're basically going to do all of our work to create the effect. And I'm just going to start by placing down a grid node, which is basically just a ground for our effect, and it kind of gives us a reference point. And in order to navigate the viewport, you left click to kind of rotate around the object, and wherever you hold the cursor is where you're going to be kind of rotating around. So if I hold it up here, it's going to be rotating around there. If I hold it down here, it's rotating around this point. And if you hit middle mouse button, you can pan and navigate the viewport that way. And right clicking and like moving your mouse will zoom in. You can do it either up or down or sideways. And this is all working now because I'm in the camera mode for the viewport, which is located right down here, this button. Sometimes you can go into selection mode by clicking this button, and you can see then that all your controls are now working as you'd expect if you want to rotate around or navigate your viewport. You can fix this by clicking Alt or holding down Alt, and then you have access to all the same controls as you would if you were in this navigation mode. As you can see, when you hold Alt, it kind of selects this mode. I like, however, to just not have to use Alt, and by pressing Escape, it'll go into this mode, and then you have access to all the same controls again. And this is generally how I like to work. Okay, now let's actually get started making our effects. And the first thing we need is obviously some geometry or a person running that we're going to be emitting the sand from. And I'm not going to be creating a model and animating it and all that. There's no reason to do that when that's already accessible online lots of places. And we're going to be using a website called Mixamo for our animation. This is actually a website by Adobe, and they have a lot of useful character animations and characters themselves here, and I use this a lot for my videos to find animations. And let's first select the character we want to use as a base, and I like this character right here. It's this alien soldier. It's just got a nice shape and kind of has a nice outline that for the emission. So you can select him by just clicking on him. And once he's selected, you want to head over to the animations tab, and search for whatever animation you would like. And I'm just gonna go for a simple walk animation. And there's a bunch of different options here. I like this one right down here. You should be able to find the same one. And it's walking. We're gonna make a big character, maybe like 15, 20 meters tall. And to get the proper sense of scale, I'm gonna slow it down a lot. So you can do that by dragging this overdrive button slider down a lot, and maybe to around 3, or I'm gonna put it to 5. And I'm also gonna set the total frames as long as possible by dragging this to -50 and 150, which gives us something like this. And I'm happy with this, so I'm gonna go ahead and download this, and I'm gonna set the frames per second to 24, which is generally what's used for film and just makes it look a bit more cinematic. And once the rest is all fine, and I'm just gonna hit download. So my animation is now downloaded, and I want to put this into my project folder. So I'm gonna go ahead and open my project, which for me, using the $home variable, is found under this PC, documents, Houdini projects, and then the name we gave it. And I'm just gonna take my download here and just drag it right in here. I'm just gonna keep it here with the hip file. And if I go back into the Houdini scene, we use a node called agent to bring it in. This basically just imports the FBX that we downloaded. I'm gonna put my display flag. So if you click on this right side, you can see it makes it blue here. This is just to visualize that particular node. So I'm gonna put it on the new node we just created, and you can see it's erroring because I haven't given it anything yet. But we can change that by changing this input to FBX, and then clicking on this file selector. And if I click the $hip variable, it's gonna go into where I place my character. And we're just gonna double click on this file to open it. And as you can see, it imports this in just a T-pose, and it's not moving. But in order to get the animation applied, we go to this current clip, and on the dropdown there should be a mixamo.com just name there. And as you can see, we now have our character animation. And it's only like about 90 frames, and then it starts looping again. And we might make it longer after, depending on how long we want the clip and the animation to be. But that's how you import the animation. Okay, so we have our animation imported, and I'm gonna start off by hitting this button right here, because if I turn it off, you can kind of see that it just plays as fast as it can, which is more than 24 frames per second, which we don't want. But if you hit it, it's gonna lock itself to 24 frames per second, and that's obviously what we want to be working in. And you can click this button to verify that your frame range or your animation is set to 24 FPS. Now that I have that done, we're gonna scale up our animation like I said earlier, and we do this by just hitting tab again and putting down a transform node. And in order to apply anything to the geometry we have to hook up these nodes, and that's done using these lines. And if you just click on this little button under the node and connect it to the transform node, you can see nothing happens. But if you select it and then mess around with, for example, the scale of the transform, you can see that the scale of our character is moving. And I think for my other Sandmonster, I've been using around a scale that's about 5 times bigger than a normal human. So if I set this uniform scale to 5, we should get a pretty big person. As you can see, these are increments of 5 for each of these grids. So this is 10 meters for his foot span, which is, he's probably around like 50 meters tall now, which is really big, and which is what we want for this. Okay, so our character animation is all good to go now. And the next step is to convert this into some usable geometry, because while it looks fine in the viewport, if you look down here, you probably won't see this. If you press D to go into your display, first of all, you can change your background color to something else here. It's probably light by default, but you can change it to dark here, like I have it. And if you go into, I believe, guides, I like to have this geometry information always on, because then I can see my primitive and my point number down in the corner. And it says 1 right now, which doesn't make sense because there's a lot of geometry making up this character. But in order to actually see it, you can put down a convert node and visualize that, which will give you all the primitives and points, which is actually making up this character. And if you hold down here and press smooth wire shaded, you can kind of see the outline of this geometry. You can also do this by just pressing Shift W, and each of these is one primitive, and every single connection point is one point. And the reason we're doing this is so we can actually do something with this geometry, like for example scatter a bunch of points onto this. So if you put down a scatter node, you'll see how your geometry just turns into a bunch of different points. And this is kind of the underlying principle for the whole effect. I'm just scattering a bunch of points onto the surface of the geometry on every frame and then just letting them fall. But there's a few things we want to change here. The first one being this relaxed iteration. If we turn this off, you can see they kind of look a bit more randomized. And that's because what this does, it kind of just tries to average out their position just to make them a bit more even. But this becomes really heavy when you have a lot of points. So if we set this to maybe 100,000 points instead of 1,000, I'm also going to set the display of the points to pixels by just right-clicking this box here. Makes it easier to see. And if I turn it off, you can see it's pretty quick. It's almost real-time. I can just generate these 100,000 points on every single frame. But if I set the relaxed iterations to the default of 10, you can see every frame takes a long time to generate, and we don't really care about evening them out when we're generating a lot of them. So instead of keeping this off, it's totally fine for our sake. Okay, so let's actually try to make a simulation out of this now. And I'll do this I'm going to set it to just 1,000 points, back to the default, because every single frame is going to get 1,000 points, and it's going to add up really quickly. And I'm going to put down a pop net. If you already have this line selected when you put down your node, it's going to just connect it automatically, which is handy. So if you search for pop, you're going to find the pop network node. And this is going to be a simulation operator, which works a bit differently than these other geometry nodes we've been doing so far. This one you can actually jump into, and you'll find this network generated for you, which is where we're going to be doing our simulation. And I'm just going to start by deleting this merge node. You don't need it, it doesn't do anything. And I'm going to set this pop source, where we're sourcing in our geometry or our particles. I'm going to set it to all points instead of the default, which is scatter onto surfaces, because we're giving it points and not a surface. And we can just hit play, and you can actually see it trail off. It's kind of a cool effect, because what it's doing is every single frame, it's generating those points and it's sourcing them into the simulation and then just keeping them around. And it's not being told to do anything else than just keep them there, which is why we get this kind of a trail effect. But if we want to add, say, gravity to this to make it drop, you can just add a gravity force and put this under the pop solver. And if you hit play now, you'll see it start dropping, which again is almost the effect itself. There's just a lot of fine tuning we have to do to make this actually look good, but this is the basic effect already made. Alright, so the next step now is obviously adding some sort of collision for this, because now as you can see it'll just fall forever, but we want it to collide with our ground. So I'm just going to put down a ground plane for it to collide with. And the way of sourcing in collisions inside of a DOP network is you want to actually use a merge node. As you can see on the merge, it has this relationship which is set to collide relationship, which means that the left input of this merge node will affect the right input, as you can see here. So if you plug this in and then use this arrow to put this left input, or put the ground plane to the left input, we'll add this as a collision object into our simulation. So if I go back to the start now, you can see this orange, that means that it's a cache, but it's out of date, there's been a change. And if you just go back to the start of the simulation by hitting this first frame, you'll see our ground plane appears. And if we play now, our sand or our particles are colliding, but they're also bouncing and have some weird behavior, but we'll fix that. And fixing that is actually pretty simple. There's bounce and friction and other parameters that we can set for the simulation. And I like doing this on the pop object itself. You can do it on the collision object too, but we just have one collision, so doing it here makes sense. And sand doesn't really bounce, but they can have a little bit of movement, so I'm going to put it to 0.1. And if we just refresh this simulation again, our sand is no longer bouncing. It looks a little bit boring, but we're going to add movement to it, and it'll look a bit more natural. once it's all finished. But at least it's not bouncing anymore. Maybe we can set it to 0.2. Might look... Actually, let's go back to 0.1. We don't want any bounce at all for this. Okay, so the base of our simulation is now set up, and we can now go back into our object area to tweak some things to make this a little bit better. The first thing I'm going to do is change how this scatter works. As you can see, there's the global seed here, which just randomizes the position of the scatter. And this is useful for us because if we randomize it on every single frame, we'll get less of a traily look. As you can see here, you can kind of see all the particles trail, which we don't want. We want these to be random, and we don't want to kind of see a pattern in here. And the way to do this is on this global seed, we're going to set a variable. I'm going to set $t, which stands for $time, which counts the frames in seconds. And as you can see, I'm on frame 25 now, and it started at 1, so 25 minus 1 is 24, and the $t is set to 1, and then it just generates the same numbers for all the in-between frames as well. Basically what it means is that every frame will now have a different global seed value, and all the particles are going to be in random spots on every frame. And if we run the simulation now, you're going to see that we no longer see that trailing pattern we saw before, at least not as much. You might see a little bit for every frame, but we can fix that too. But the main problem is now solved, and this looks already better. Okay, let's start refining the shapes of the simulation. Right now, it all just drops straight down, but it's a lot more interesting if there's a little bit of wind or some turbulence affecting the particles as they drop to give them some shape. And we can do this with a node called pop wind. So put down a pop wind, and we're gonna put this one in between the source and the solver, because this input is post-solving. You could also put it here in the pre-solve, but it'll basically just do this before the gravity and the collision. And by default, it won't do too much. It'll kind of just slow down the particles because it's adding air resistance to the simulation. As you can see here, an air resistance of 0.1, which is a lot more than we want in this case. If I set it to 0, it's basically just not doing anything. I'm going to set it to 0.1, so there'll be a bit of air resistance, but not too much. It'll still look natural. Because we need a little bit of air resistance in order to apply our force. And 0.1 will be enough for our case. And let's just set the amplitude of this noise. So this, all the parameters down here is making the noise or the turbulence field, which is basically just a random wind that's blowing. And let's just try 1 and see what it gives us. It can't really see much. And when that happens, I generally just like to set it really high, let's say 10, so we can see if there's anything happening at all. And yeah, now you can see it's working. The particles are just going all over the place, which obviously we don't want either. We can maybe try a value of 3, which gives us a bit more natural look, but it's still a little bit hard to see. There's this swirl size, which we can also change. What this does is it basically just changes how big our noise field is, or like the different sizes. I can show it by setting this back to 10 and then setting this to 5. As you can see now, these are a lot bigger shapes, which makes more sense for our big simulation. It looks kind of cool like this compared to when it's set to 1, and these shapes are just a lot smaller and just all over the place. So I'm going to set this to maybe like 4. We can test it at 10 to see the pattern. Looks like a nice pattern, and then set this back to, let's set it to 4 for the amplitude as well. And it's not super noticeable, but there's definitely some movement in here now. You can see like the head here, you can see kind of fling off there. It just looks cooler and generates a lot more natural shape when it hits the floor. It also moves around on the floor, which we don't necessarily want. It could be a cool effect. Maybe we'll keep it actually. It could be nice. But anyway, so this is just how you add some detail into your simulation. So usually I'd make the grain or the particles just stop as they hit the ground. And you can do this by going into your pop solver. On the collision behavior, click add hit attribute and setting it to stop, which will just make them stop as they collide. But I actually think it's kind of cool what they're doing. So I'm just going to hit Control Z to go back, and just having them kind of slide on the floor looks kind of neat. So if you have a camera here, you can kind of see them start branching out on the sides and everything. And yeah, let's just keep this effect for the tutorial. I think it'll be cool. And we basically have it set up ready to go now. I don't think there's too much more we can do to the simulation. One thing we could do to get rid of these is we can add a sub-step where right now it's simulating on every single frame, but we can make it simulate on like 2 times per frame by setting this min sub-steps to 2. This will take twice as long, but we'll get some more details in between the frames. But for our sake, I think it's fine. We're not going to really see that much difference, and it'll just take longer for us. So let's just keep it at 1 and set up the caching for the simulation. Actually, one thing we'll do before we cache the simulation is fixing what happens when this animation starts looping. As you can see, it runs through the whole animation cycle, and then it kind of resets back to the start, which is kind of a neat effect, but we don't really want that in our case. Something we can do is kind of loop it so that it just keeps going forever, but I think what we'll do, which might be cool, is just have it stop right there and then just kind of see it all drop down to the ground. But we don't want it starting again, so what we can do is just switch off the simulation right on this frame here. On frame 89 is the last one we want to keep. So go into your pop source, go into your attribute or into the birth, and you want to click Alt and then left click on this, and that'll make it green, which basically just sets a keyframe. And a keyframe will just animate this parameter, because what this parameter does is it just tells the simulation or the solver if we're going to be sourcing in the particles or not. And set to 1, it will be sourcing. Set to 0, it will not be sourcing. So if we go to frame 90, obviously we didn't want this in here now, so we're going to set this to 0, and again Alt left click. So if we go between the frames just using arrow keys, you can see you can still see it there, but if you keep playing, there won't be anything sourcing. You can turn off the blue visualizer here by just hitting this check mark on the guide. And if we now go through the simulation, you'll see that on frame 90 it stops emitting, and this should lead to a pretty cool effect. When we have a lot more particles as well, it'll be cooler, because we'll add a lot more particles to this simulation for our cache, because then we'll just let it run and we'll just save it to our disk. Which leads me to caching, which is exactly what I said, by just saving all of these geometry files or the points onto our disk, so we didn't have to constantly run the simulation. And we can also just boost the amount of particles and just do it once, and then we can just return to the same cache, so we don't have to, when we're rendering and doing other things to the simulation or doing stuff after the simulation, we won't have to constantly resim, because you can see every time I sim it now, it takes maybe a few seconds, but when we add a lot more particles, this can take minutes, hours, and at the most even days when you're making really big effects. So let's get to caching. We're gonna go ahead and jump out. You can press U to go up 1 level, or just click here to go up 1 level. If you visualize this node, you can see our geometry, but we also see our ground plane, which we don't want to bring out. We just want to bring in the particles, and this object is kind of telling us what we're bringing out of the simulation. And star will just bring everything. Star is just a variable that's used to bring out everything we see inside. But we just want to bring out this pop object, which is containing our particles themselves. So I'm just going to double click here, Control C to copy it, and then paste that in here, which will just bring out our particles and not the grid. So now we have this, and one thing we want to do before saving this is we actually want to put down something called a rest position. We're going to put this in front of before the simulation. And what it'll do, it'll store the position of each point as they're created. It'll store this position, but it'll remember that position even when it moves through space. And this is very useful, because we want to add some noise, and we want to add some color to this, but we don't want the color to change depending on where it is in space. We want it to change depending on where it was when it was created. We want it to stay constant. So this is just a useful note for that. It'll make more sense when we actually add the color. And the next step to prepare this for exporting is to delete some attributes we don't want. Attributes, if you middle mouse, you can kind of see that there's a bunch of 17 point attributes. A lot of these are not useful for us, but every point attribute we have will be stored on the disk, and it'll just take up space that we don't want to take up, and it'll just be slower to load, and it's just useless to keep them. So what we can do is put down an attribute delete node, which will allow us to delete all these different attributes. And instead of telling them what we want to delete, I'd rather just tell this node what to keep. And you can do that by using the same star variable. If I do this, you can see they're all gone. Now there's nothing here, just the position one, which is impossible to delete. You can't delete the position of the point. But if you use this tick here, which you can make on Windows by pressing Shift 6, and then I can, for example, write ID, and now you'll see that it'll keep the ID attributes. So it'll keep position, of course, and then it'll remove everything but ID. And we can set some other attributes here that we want to keep for later, which I'll show you later, like why we're keeping these. But for now, you just want to we want to keep H, and we want to keep the rest position we made, and also V, which is velocity. And you can visualize it with this one. It kind of just shows which direction all of our points are going in, which is used to like motion blur the image later on. Again, I'll explain this in the rendering phase, but for now, just make sure to keep all of these, and then we can just delete the attributes on all the other, on the vertex, primitive, and detail. We just delete them all. We don't need them. We just need these point ones. And with this, we're ready to save it to the disk using a file cache. So again, the file cache, all it does is it just saves this geometry onto our hard drive or our SSD, whatever you might have. And we can do this by just hitting the save to disk button. I'm just gonna, actually before I do that, let's set up some names and stuff and like choose where these files actually end up. As you can see by default, it goes into hip geo, and then it sets the name here. And this is a fine place to put it. It goes into all the folders we created before and into the geometry folder, which makes sense. And then this right here is setting up the name. I'm just going to remove it and kind of recreate it. So for our name, I'm just going to put $OS. $OS is basically just this name. It's the name of the node. So it's whatever name we give it here. It's going to be this. It's going to be this variable. So if you middle mouse on it, you can actually see where it ends up, or what it's called, and it goes into our path, the whole path for our Houdini project. And then the final one is called file cache, which is the name of this, which is our $OS variable. I can call this cache sand particles, and I'm just going to do v1 as version 1. Now if I middle mouse on it again, you can see the cache itself is called cache sand particles underscore v1. You can't put spaces here. It'll automatically use underscores, and that's just because spaces sometimes messes up how files are read, and it can error out, so it just automatically generates the underscores. Now to further set up this, we want to add a $F variable. So I'm just going to do $F dot, and what this does, it sets a variable for every frame. So this will be frame 40, 38, 27. Again, middle mouse, and let's go look at it, and there it is. So it's 27 because we're on frame 27. And the reason we're doing this is we need to actually save a file for every single frame here. We can't just save one big file. We want to save a single file for every frame because it's changing every frame. And this will do that. It'll set up the names properly for that. And lastly, we want to set the extension, which is what type of file it is. And Houdini has a file, like a native file name, just called bgeo, and then .sc. That's the basic, I think. And if you control middle mouse, you can actually go back to default, just to make sure that's what it's called. And with this, we should be able to actually save to disks. And I'm just going to do this. It shouldn't actually be too long. I haven't added too many more particles. It brings up this window where you can see your job, and it kind of goes to completion. I'm just going to interrupt it because we don't need to go all the way there. And actually, right now it's actually still loading from the cache, or from the simulation. But if we hit this load from disk button, even if I disconnect it here, you can see we're loading in the files. And if I go here and turn off the sequence, you can see all of our different files. Every single frame has one file now, which are all about 3 megabytes each, which is not that bad. And if you click the show sequence as one entry, our whole cache is about 300 megabytes, which is, I mean, it's going to add up. If we add a lot more particles, we're going to get a few gigabytes of the file here, or in file size, which is fight for our case. But yeah, this is how you set up cache. Now let's just further prepare the scene for rendering and caching the final version. And the first thing I'm going to do is just change the frame range, because right now you can see it just keeps on going and it will cache all the way, but we don't need it to last this long. So I'm going to set it to around frame 130. It's a good place to end it, I think. And you can do that by just changing this to 130. And now this one will automatically just go to the last frame in our range. So it'll only cache 130 frames, which is good. Well, we're also going to turn on this initialize simulation ops. What this will do is just ensure that the simulation is kind of starting fresh when you simulate it. It won't use an old cache and mess up. Because what could happen is we changed it to use a lot more points, but it still has an old cache in there that's using less points, and it'll cache that instead of our new one. So that just ensures that everything will be nice and fresh when we hit save to disk. And I'm also going to put this missing frame to no geometry instead of reporting an error. That's just in case we have one frame where we don't have any geometry. Instead of us giving an error, like if I go beyond here, it would normally give us an error, but I just like having this in no geometry so that when we render, it won't like cancel the render. It'll just keep going with nothing there, which is what we want. And now I think this node is all set up. And let's just do a cache where we maybe do 4 times as many particles. So on this force total count, I'm gonna do times 4, which will give us 4,000 particles per frame. And let's see what happens when we save this to disk. Alright, so the cache is done, and as you can see, we have a lot more particles now. It looks a lot nicer and there's a lot more details, and you can see the points here in the corner. It's already up at 300,000 points. At the final, it's at 356,000 points. But still, it was really fast, at least on my computer. It really depends on what kind of computer you have, on how fast this will take and how much you're able to kind of store on your computer. But this should work on most computers. And I think this is what I'm going to use for now to work with it. Later on, I'm going to do like a lot higher one where we have millions of particles. But for rendering and shading and stuff, it's better to do that on a lower amount where you can do it pretty quickly. And then just boost the amount later on, so it just makes for quicker iterations, and it's just easier to work with, as you'll see. So let's use this cache when we start to prepare this for lighting and rendering, which we'll do in part 2 of this tutorial series.